Good morning. Here in the thumbnail, you have seen the topic, the power of quantum computers. I have written here only quantum computers, the power of quantum computers. This is the topic. So, most often what we face with our present day computers is that speed of the computers. Okay? If you are a student of science, I think you know this thing. Yes, many tasks are being accomplished by the use of digital computers, but not all the tasks, such as analyzing the formation of black holes, galactic evolution, formation of supernova, means analysis of all those things. Then if you talk about security, you know one word that is called hacking. Okay. So in case of digital computers, hackers are frequently hacking according to their requirements. Okay. Then modeling of medicines on molecular level for the diseases like Parkinson's disease, cancer, Alzheimer's disease, etc. Then, say for example, production of fertilizers using only nitrogen gas, etc. Many problems are there which are beyond the scope of digital computers, present-day digital computers. Okay, many things are there. So, in the world of computers, first appeared analog computer, around just 2000 years back, analog computers was discovered. Then came digital computers, and you too is habituated in using digital computers. Now we are talking about quantum computers. Yes, researches are going on in this field, and we are very close to the discovery of these quantum computers. It has huge memory, okay, and it is super faster. The speed of a quantum computer, it is estimated that it is few million times faster than the digital computers. Few million times faster. I am giving you one example. There are certain problems which would take almost 10,000 years of time if you use digital computers. Yes, 10,000 years of time. But if you consider the speed of a quantum computer, then it would take merely 4 minutes. Only within 4 minutes of time, the same computation can be accomplished by using quantum computers. So where is the difference? In case of digital computers, transistors are used. Okay. But in case of quantum computers, transistors are not used. There is the difference. In case of digital computers, bit, this term you know, I think, that is used, and that can be either 0 or 1. Only two states are there, 0 and 1. In case of digital computers, only 0 and 1 are there. And in case of quantum computers, since superposition of states, according to quantum theory or quantum mechanics, you know superposition theory. Okay, superposition of states. According to that, only 0 and 1 will not be there. In between 0 and 1, there are so many possibilities. Infinite number of possibilities are there. And each possibility can be used to build a for the calculation purpose. Okay. So superposition states as well as quantum entanglement. You know that to transfer information from one state to another, it takes no time in case of quantum entanglement. So the power of quantum entanglement as well as the power of superposition of states, both the things will be used for the production of quantum computers. But there is one problem. Problem is that at room temperature, this cannot be done due to decoherence problem. Here, computers, means quantum computers, will act on atoms, will compute on atoms. So, electrons will come into play, come into picture. Okay, electrons will come into picture, and you know that electrons are associated with waves. I think you know this thing. Electrons are associated with waves. If you study quantum mechanics, then you will know this thing. Electrons are associated with waves. And say there are many electrons are vibrating together. So when the waves are in phase, coherence occurs. They vibrate in unison. Okay. And when they are out of phase, decoherence occurs. So for the purpose of quantum computing, coherence is required. And coherence, this thing can be achieved only in low temperatures, as low as near to absolute zero. So this much of reduced temperature is required. That is a big problem in case of quantum computers. But Mother Nature has already solved this problem very easily at room temperature. Just for example, if you take the example of photosynthesis, then you will find that photosynthesis, this is a quantum mechanical process, and this happens at room temperature. Okay. So we can say that Mother Nature is still smarter than us, means smarter than human beings. Anyway, we are not going to that thing. We are now talking about, in this lecture, I am interested to talk about only the power of quantum computers, not supercomputers, quantum computers. Okay. So I have already given you one example that the task which takes 10,000 years of time to solve using digital computer, the same task can be accomplished by a quantum computer within 4 minutes of time. Okay. And many problems are there which can be solved by using quantum computers, but their problems still exist, but since we don't have at present quantum computers in our hand, so we are not able to solve those problems using digital computers. There is a difference. Okay. In my next videos, one of my next videos, I'll discuss in detail the why superposition of states helps in speeding up the process of computation, and also what is the role of quantum entanglement in making the computation faster. Okay, these two things will be discussed in my another video. Okay, I think the purpose of this video was only to talk about the power of a quantum computer and nothing else. Okay, so I think I have already mention the power and the need of quantum computer. What is the requirement of quantum computer? Okay, you just keep in your mind that there are so many problems. Those problems are waiting for the invention of quantum computers. If we can really invent quantum computers, then those problems, those pending problems can be solved at ease. Okay. Okay. So I think this should be the end of this lecture. Thank you. Thank you for watching this video.